World. So we are back into our fifth lecture. Now today we are going to see Bluetooth. So Bluetooth, we all know that Bluetooth operates at a frequency range of 2.4 gigahertz. Bluetooth operates at a frequency range of 2.4 gigahertz. It uses frequency hopping and time division multiplexing scheme for transmission of data. So I'm Satyaraj, assistant professor working in R.M.K. CET. So the idea behind the Bluetooth is that why we go for Bluetooth rather than using WLAN technologies. So the Bluetooth having we can say the Bluetooth to be ad hoc piconets. So why we call this Bluetooth to be the ad hoc piconets in sense we have different local area networks with a limited coverage area, right? And we need infrastructure for the network. So without infrastructure, it cannot work. So here with respect to 10-meter distance, at least for 10-meter distance, we need to transfer the information in a wireless medium without using any expensive wiring system. So because of that, to get a data rate of 1 mbps, to get a data rate of 1 mbps and to cover within a distance of 10 meters, they have found a new device called Bluetooth. So with respect to the scientist Ericsson, he has found the Bluetooth. So Ericsson, he has found from the idea that Bluetooth radio system is began by Ericsson mobile communication during 1994, right? So he has found this universal radio interface for exchanging information through ad hoc wireless connectivity. So here we can also connect with a personal computer and other peripherals and other handheld devices, personal data assistants, cell phones, and here in Bluetooth we are replacing the infrared technology. And here we can embedded in other devices, and distance is 10 meters already I told, and power is low power, so it consumes low power and working in a license free band of 2.4 gigahertz ISN. And using Bluetooth you can exchange the data with respect to voice and data transmission approximately with a data rate of 1 mbps, right? So this is the Bluetooth device which is exchanged in wireless medium with a distance of 10 meter. So the history behind this Bluetooth is that in 1994 Ericsson has found with his project. So we no need of going in depth with this. Special interest with other members is that Ericsson, Intel, IBM, Nokia, Toshiba, many companies came forward and they have promoted with respect to the third generation telecommunication with respect to 2500 members, and common specification are the certification of products. So Ericsson, what he do is that the main aim that is he has a carving. So in this carving, it was interpreted Bluetooth by connecting a cellular phone and a wireless notepad in his hands during 1999. So through this, he exchanged that is exchange of data transfer takes place, right? So this is the real runstone. So the characteristics of Bluetooth, it operates on 2.4 gigahertz with a ISM band and 79 RF channels and 1 megahertz carrier spacing. So channel 0 when we use from channel 0 to channel 78, starting from 2402 megahertz to 2480 megahertz. It uses Gaussian phase shift keying modulation and transmit power from 1 to 100 megawatts, and frequency hopping spectrum and time division duplexing. So this is the how much hops it is having is that it has 1600 hops per second. So the it is divided with respect to 1600 hops per second. The time between the two hops is nothing but one slot. Time between two hops is nothing but one slot. So one slot consists time period of one slot is 625 microseconds. This is very important. The time division duplexing for sending and receiving the separation of the information. So voice link can be established by means of SEO. SEO is nothing but synchronous connection oriented, and data link can be achieved by means of ACL. ACL is nothing but asynchronous connectionless. So for using SEO, we can establish the following things: forward error correction, no retransmission, 64-bit kbps data rate with full duplex, point to point also we can do, and circuit switch communication. And here it is with respect to ACL, asynchronous fast acknowledgement point to multi-point up to the data rate of 433.9 kbps for symmetric and 723.2 or 57.6 kbps for asymmetric. It uses a technique called packet switched transmission. So the topology for the Bluetooth is that overlapping of the piconets forming a scatter net. I'll explain what is piconet and what is scatter net. So piconet is nothing but it is a collection of devices in an ad hoc fashion. So in this diagram we can see that P stands for part mode, S stands for slave, and M stands for master, and SB is nothing but standby mode. So I'll explain what is P. P is part mode, and S is slave, and M is master. You have a single master followed by 7 slaves. So one unit acts as a master and other forms as slaves. So one master and 7 slaves, which detects the lifetime of the piconets. So master determines the hopping pattern. So with this master is will be determining the hopping pattern, and slaves will synchronize with the master. And each piconet has a unique hopping pattern. So each and every piconet has a unique hopping pattern. It can either use FHS or other schemes. So participation in a piconet which is equal to synchronization of the hopping sequence. So each piconet has one master and it will have 7 simultaneous slaves. So 3-bit address is used for the Bluetooth device. So forming a piconet. So coming back to the piconet. So using piconet, what can we establish? So by the piconet, we can establish that is 200 active slaves can be participating. Master can handle 7 simultaneous slaves, and standby mode. That is a mode which is used to wait for the piconet to join, right? So a node called P. P is nothing but which is the part node, which is used for low power connection. P is said to be used in low power connection. So for example, when the device is used in part mode, P mode stands for part mode and A mode stands for active mode. So P is the part mode. So if a device is used in a part mode, we can say that the terminal of the mobile, it will that is a Bluetooth device, the terminal of releases its MAC address by standby mode by keeping its own MAC address. So we can say that two or more piconets combine together by forming a scatter net. And for example, if we say that standby mode, so in the standby mode, if suppose one of the devices in part mode, and which is ready to communicate and is about to communicate with other slaves, one slave has to switch to part mode. So one slave has to switch to part mode and to allow the part device to switch to active mode, right? So Bluetooth devices, we use as Gaussian shaped frequency shift keying, and modulation index of k is equal to 0.3, right? So we have different layers in the piconet with respect to scatter net. So the piconet, all devices in a piconet hops together with respect to same similar frequency hopping pattern, and the hopping pattern will be determined by the device ID. The device unique, it will have unique ID, that is 48 bits followed by the unique worldwide ID, and phase will be a hopping pattern determined by the clock. So we have two members of addressing. One is active member address, another one parked member address. So the active member address is 3-bit and the parked address is 8 bits. And another one SB, which is nothing but standby mode. The standby mode does not have any address. So this is of the standby mode to the active mode. So from the standby mode to active mode, some of the devices will be still in standby and some devices move to the active mode, followed by a one master with 7 slaves. So this is a scatter net. Combination of two piconets form a scatter net. So M stands for master, S stands for slave, and P stands for part mode, and SB stands for standby mode. So here, linking of multiple co-located piconets through sharing of the common master or slave devices is said to be scatter net. devices can be slave in one piconet and master of another piconet. So it can be a slave of one piconet and can be a master of another piconet, depending upon the capacity. So the capacity of the piconet is 720 kbps. So the device jumping back and forth between the piconets can communicate between two piconets. So this is the Bluetooth protocol stack. So in the Bluetooth protocol stack, we have the radio layer, baseband layer. First layer, lowermost layer is the radio layer. Second layer is the baseband layer. The third layer, which is in between the logical link control and adaptation layer, L2 cap layer and the link manager. This is the link manager which connects the link between the baseband as well as logical link control. And next is RF communication. Then BNEP stands for Bluetooth Network Encapsulation Layer. Triple P stands for point-to-point protocol. IP stands for Internet Protocol. We all know that TCP UDP is Transmission Control Protocol and User Datagram Protocol. And OPEX is nothing but Object Exchange. And SDP stands for Service Discovery Protocol. So TCS, we know that TCS binary. So and then remaining are the applications. So here in this diagram, we can say that we have multiple core networks connected with respect to different applications. So each and every network is responsible for providing the that is radio network. In the radio network is a lowermost physical layer network. It provides a specification of the air interface. Example, frequency, modulation, and transmission power transmits power. Okay, so this will be done in the radio network. Next is your baseband network. So in the baseband network, it is used for connection establishment. Okay, so connection establishment and link creation, packet formats, then timing and maintaining the QoS parameters. Timing and maintaining QoS parameters. So all this thing will be done here. Link manager. What this link manager will do? It will connect the link setup and management, right? And link setup and management it will do. Link setup and managing. That is the link manager work. So next is logical link control and adaptation protocol, L2 cap protocol. So this L2 cap protocol which provides adaptation to the higher layers to the baseband layer. So baseband layer is the lower layer and higher layers are nothing but the above layers. IP layer, that is with respect to network layer and transport layer and application layers, all these layers. So it provides connectionless and connection oriented services. That is the purpose of using L2 cap, both connection oriented and connectionless. Connection oriented and connectionless. So we have a protocol called Service Discovery Protocol. So the Service Discovery Protocol, STP stands for Service Discovery Protocol. So what the Service Discovery Protocol will do is it will just discover the discovery in the closed proximity with respect to the QoS parameters. So we will discuss this later since we will be learning the L2 cap layer in detail. So when we are learning L2 cap layer in the next lecture, we will be learning more about the service discovery protocol. Just to remember that service discovery protocol is used for device discovery, right? Device discovery. And next is the top of the L2 cap is a cable replacement protocol, which is called as RF-COM. So RF-COM acts as a serial line interface. Usually, it will be following RS-232 standards. It will have lot of cables to connect the upper layers and legacy protocols to run over the Bluetooth. And RF-COM, which will be supporting serial ports over a single physical channel. And next protocol is nothing but TCS WIN, which is telephonic control protocol. So TCS stands for telephonic control. So what is this telephonic control protocol will do? So this telephonic control protocol describes a bit oriented protocol which is used for call control signaling. Which is used for call control signaling. Next is your HCI. HCI will be present inbuilt, which is the host control interface. Host control interface, which is the interface between the That is, this is the interface between the baseband layer and the logical link control layer. And we have the specification in radio layer. So the radio layer will have three power specifications. One is class 1, class 2 and class 3. Class 1 is capable of holding 100 megawatts and minimum power of class 1 is 1 milliwatts. And the power control is very important in case of class 1. So maximum power in class 2 is nothing but 2.5 milliwatts and nominal power is 1 milliwatts. And minimum power needed is 0.25 milliwatts. That is Bluetooth distance based on the distance 10-meter range without the obstacles. And last one is nothing but power class 3, which is having a maximum power of 1 milliwatts. So next is your baseband layer. So in this baseband layer, we have the different components of Bluetooth which is connected to exchange the packets. So with respect to baseband, we have low level packet definition. So with respect to low level packet definition, we have access code followed by packet header. So access code followed by packet header with respect to payload. So what is access code? Access code is the first field of the baseband. So in this field, it is used for time synchronization. Mainly, this is used for time synchronization. So why it is used for time synchronization? In sense, for the transmitter, the packets have to be sent from the with respect to preamble, synchronization, and trailer, and then active member address. How many fields are active? And the trailer part, you have the packet header followed with the trailer part, and then we have the special address, lower address part followed by the payload. So this is with respect to flow control and error control. So it follows the acknowledgement and then followed by sequence number and header error check, right? So you have two things to remember. One is 1 by 3 forward error correction, and 1 by 3 forward error correction means it will have to transmit plus 7 slaves. One will be master and 7 slaves. It follows the link type with respect to ARQ and sequence number followed with checksum. So next is frequency selection using the during the data transmission. So how it will select the frequency with respect to data transmission is that it will be having a slot of 625 microseconds. Master following a slot of FK. So it will be having rate of 625 microseconds, and slave it will be have with a frequency of fk plus 1, and then next master will be having fk plus 2, etc., up to fk plus 6. So this is of first transmission. So in the first transmission, you have two masters followed by two slaves. So here it has a 3-bit address. Next it has a 5-bit address. So for the 3-bit and 5-bit, so the difference between this 3-bit and 5-bit is used for different packet transfers. So next is SEO payload types. So in SEO payload type, we have payload followed by 30 bits. So payload followed with respect to 30 bits, and 10 bits is for audio and 20 bits for forward error correction, which is for HV1. And that is nothing but high. So H with respect to the first one, the second one is audio with respect to 20 bits and forward error correction of 10 bits. Then audio of 30 bits followed by 10 bits for audio, header 1 bit, and payload 0 to 9 bits. And here you are using 2 by 3 of the forward error correction. And CRC stands for cyclic redundancy checker, followed by 2 bits. Then for asynchronous connection link, you have the payload type for symmetrical. If you are using symmetrical channels, you will be using 433.9 kbps of data speed, and if you are using asymmetrical, 7 kbps. So here you have the payload which is 0 to 343. So the header will be having 1 by 2 of the part, the payload followed by 0 to 339 and cyclic redundancy check 2 bits. Here we have DM1. DM1 is data medium rate 1 and followed by the data high rate 1. Then data medium rate 3 followed by data high rate 3. Data medium rate 5 followed by data high rate 5. So when we go back to the previous diagram, we can able to easily understand. Here it is 1 bit, here it is 3 bit, and here it is 5 bit. So we are using this data medium rate 1, data medium rate 3, and data medium rate 5. Similarly, data high rate 1, data high rate 3, and data high rate 5. So baseband link types. Here we are using the polling based time division duplexing packet transmission. Here you will be separated with respect to 625 microsecond slots and master flow polls the slaves. Here for voice we are using SEO and for data we are using ACL. So 135 slots for variable packet size, and here we are following asymmetric bandwidth with respect to point to multi-point. But in case of SEO, point to point, right? So this is a master followed by slave 1 and slave 2. So here we will be achieving the data rate of 433.9 kbps for symmetric and 723.3 for asymmetric. And this high quality voice packets always uses a single slot, but it is different with respect to the redundancy. So next is robustness. So when there is a data transfer, some ACL only it will be very fast, and the error in the payload, but it will not be indicated in the header. So here it is a negative acknowledgement. So when the negative acknowledgement comes, we can able to find that we have some error. So we have to eliminate the error, and when we get the acknowledgement from the master. Next, these are the different states of the Bluetooth. So the different states of the Bluetooth includes inquiry state, page state. That is, when the Bluetooth is not connected, it is said to be unconnected state. That is standby state. When the Bluetooth is connected, we can say that it is in connecting stage. During connecting, we can say that it will be in inquiry or page state. So AMA stands for active member address. And in the standby state, we can say that it won't do anything. It will be simply without doing anything, it will be idle. So in inquire state, it will search for the devices where the Bluetooth devices are ready for the connection, for establishing connection. Then in page state, it will connect to the specific device, and when it is connected, it will start to participate with respect to piconet, and then it forms a scatter net. So we have when it is connected, when the active member address is connected, we have park mode, hold mode, and sniff mode. In park mode, it will release the active member address and get the um, parked member address, and in sniff mode it will listen periodically, and it will not periodically listen for each slot, and it will hold state, it will hold with respect to ACL, asynchronous connection link, and SEO will still it will be existing, and it will participate in another piconet. Why we use all these states of Bluetooth? To save battery. So these are the examples of Bluetooth wireless adapter. So thank you for your patient listening. We'll see in the next video. Please don't forget to subscribe our channel. Thank you.